Okay. No. Okay, now. So now we want to put all of the things we learned today back together so we can just sketch the graph of the quadratic. So the first thing we want to do is to find the roots, and that's going to be the easiest thing. Remember, the roots are also called the zeros of the function, and that's when y or f of x, same thing, equals 0. So we'll just rewrite the equation as 0 equals x squared plus 6x plus 5, and then we'll solve it. To solve this, it's already in standard quadratic form. I have 0 by itself, and I have x squared plus 6x plus 5. So I want to go ahead and look for a greatest common factor first. Since that's 1, then I'm just going to move on, and I'm going to use the box method to factor it. So I have x squared in the top left corner, and 5 in the bottom right. And to find the values that are going to combine to give me 6, then I'm going to multiply my first and last term. So I have x squared times 5, so that's 5x squared. And I want to find the factors of 5x squared that will combine to be my middle term, 6x. So my factors, of course, will be 5x is a factor of 5x squared, and just 1x, or x, is a factor of 5x squared. So that goes into my other two boxes. Now, the last thing I want to do is find the greatest common factor of each row and each column. So the greatest common factor of the top row is x, bottom row is 1, left column is x, right column is 5. I look at my signs, and since this one is a plus, I know they're going to be the same in here, in my two parentheses, and this one is also a plus, so that means they're both going to be positive. Everything's positive. We're all happy, happy. So I have x plus 5 is one factor, and I have x plus 1 is my other factor, and that of course is equal to 0. So now I just want to make a little t and find the values of x that make this equation true. So I have x plus 5, and I want to set that equal to 0 because if one of the factors is 0, then that's the only way I can multiply to get 0. So x plus 5 equals 0, and x plus 1 equals 0. Solve both of these equations, and I get x equals negative 5, and I get x equals negative 1. And those are my roots and the solutions to this equation. So I want to hang on to those. I'm going to use them again in a second. Now I need to find my line of symmetry. So hopefully you remember the formula for the line of symmetry. Remember, that's a vertical line, so it's going to be written as x equals something. That's the line that goes right through the middle, right through the vertex. So it's going to be written as x equals, the formula again is negative b over 2a. b in this case is 6, and a in this case is equal to 1. So plugging that in, I have x equals negative 6 over 2 times 1, which is of course negative 6 divided by 2, which is negative 3. So my line of symmetry is x equals negative 3. The really important use for the line of symmetry is to find the vertex. Remember, the vertex, my graph has that swooping shape, and the vertex is where it starts to swoop back up. It's the lowest point in this graph, or the minimum of the graph in this case. It could have a maximum, but this is a minimum. And I know what the x value is because my line of symmetry goes right through it. So the x value is negative 3. So I know that when I have my answer, the x is going to be -3, and what I need to find is the y. So to find the y, I just want to go ahead and plug it right back into my original equation, plug x in. So if f of -3 equals, remember that it's whenever you replace a variable, you always put it in parentheses. So if -3 squared plus 6 times -3 plus 5. -3 squared is 9, plus 6 times -3 is 18, or rather -18, so I have -18, and plus 5. 9 minus 18 is 9, so -9. So -9 plus 5, and that's going to be -4. So my line of symmetry is, or rather my vertex, the point where the graph turns is x equals -3 and -4, comma -4. So the y is -4. And I want you to go ahead and watch the next video, which is going to show you how to use all of this information to make a sketch of the graph and get an idea of what that graph looks like.